Every day, we walk on the surface of our planet, and it seems to us that Earth is incredibly huge. To us, it's an entire boundless world, with the deepest oceans, the highest mountain ranges, and billions of people scattered across continents. But the moment we look up at the sky and view the cosmos through the lens of mathematics, our pride instantly vanishes. On the scale of the solar system, our home is just a tiny blue speck of dust. So you can grasp the real gap in size. If we imagine Earth as a regular pea, Jupiter would be the size of a large watermelon, and our Sun would be a sphere as tall as a 2-story house. The diameter of our star is 109 times larger than Earth's. You could easily pour over 1 million planets like ours straight inside the Sun. In Universe Sandbox, we often destroy Earth, smash it with asteroids, or throw it into black holes. But today, everything will be different. Today, we are giving our planet a chance to fight back. We will gradually increase the size of Earth, step by step, turning it into an absolute cosmic monster until it matches the exact size of the Sun itself. But before we begin, I must lock in one crucial rule in the simulator: density. I am putting a lock on this parameter. If we just inflate Earth like a balloon, it will turn into an empty void. No, we will preserve its composition. It will remain a solid, rocky, and iron planet at every stage of its growth. And believe me, it is exactly this fact that will break the physics of the entire solar system in just a few minutes. Let's go. To start, let's not rush things. I'm putting the simulation on pause. Let's increase Earth's radius by just 3.8 times. Now, our planet exactly mimics the size of Neptune, the ice giant from the outskirts of the solar system. But remember the density rule? Because we increased the radius nearly 4 times, the planet's volume grew according to the laws of geometry. And along with it, the mass increased colossally. Right now, before you, is a rocky ball that weighs 60 times more than the original Earth. What happens if I unpause the game? For every living thing on the surface, it will be the end, and an instant one at that. Gravity jumps to nearly 4G. This means a person weighing 70 kilograms would suddenly feel a concrete slab weighing 280 kilograms placed on their shoulders. Our hearts simply wouldn't be able to pump blood to the brain. Not a single building would stand. Skyscrapers would collapse into themselves under their own unbearable weight. The atmosphere would compress into a thin, ultra-dense layer, and the pressure at sea level would become like that at the bottom of the Mariana Trench. But the most mesmerizing and terrifying sight is unfolding in orbit. Look at the Moon. Our faithful companion, which has accompanied Earth for billions of years, finds itself in a deadly gravitational trap. Earth-Neptune's gravity, strengthened 60 times, sharply slows the Moon down and pulls it toward itself. It won't just fall. According to the laws of celestial mechanics, there is something called the Roche limit, the distance at which a large planet's gravity exceeds the satellite's own gravity. As soon as the Moon crosses this invisible line, monstrous tidal forces begin to literally tear chunks off it. The Moon cracks at the seams and falls onto the Earth. Earth-Neptune is getting cramped, and we need more scale. Let's raise the stakes and increase Earth's radius to 11 times its original size. Now our rocky planet exactly matches the size of Jupiter, the undisputed king of the solar system. And this is where true science fiction begins. Jupiter is massive, but it's made of light gases, hydrogen and helium. Its average density is just slightly more than water, but our super-Earth consists of heavy silicates and an iron core. At the size of Jupiter, the mass of this rocky anomaly exceeds the mass of the original Earth by almost 1,400 times. We have just created the heaviest rocky planet that could possibly exist according to the laws of mathematics. The first thing that catches the eye is that Earth changes color. It begins to glow ominously with a dim red light. Why? Because of its own insane mass. Gravity presses down on the center of the planet with such force that the iron core heats up to tens of thousands of degrees. this heat bursts outward, melting the mantle and the crust. The entire surface of the Earth turns into one continuous boiling ocean of red-hot magma. There is no more land or water on this planet, only an endless storm of liquid rock. The second change affects our neighbors. Before, Earth was a modest planet that didn't influence anyone. Now, it weighs as much as 4 Jupiters combined. Its gravitational tentacles are spreading throughout the entire inner solar system. Look at the orbital lines of Mars and Venus. They begin to distort, turning into stretched spaghetti. With its massive gravity, Earth has pushed Venus entirely out of its orbit. Mars leaves its usual path and begins a dangerous dance of death, which will inevitably end in either a collision with our blazing super-Earth or the ejection of the red planet out into cold interstellar space. And now, the moment of truth, the final act of our experiment, the very reason we started all this. I am increasing Earth's radius by exactly 109 times. Now, Earth is a perfect 100% replica of the Sun in size. 2 giants stand facing each other in pitch darkness. But before I hit the play button, think about these numbers. As I said before, the Sun is a scorching but very light gas. If you could scoop up a piece of the Sun the size of a sugar cube, it would weigh just over a gram. That same cube of Earth weighs 5.5 grams. By increasing the rocky planet to the volume of the Sun while maintaining its density, Earth's mass increases by 1,300,000 times. Do you know what that means? It means that our rocky Earth, right now, has become almost 4 times heavier than the Sun itself. We unpause, and the simulator's physics go insane. According to the laws of astrophysics, a rocky object of such monstrous mass simply has no right to exist. The pressure in the core of this mega-Earth reaches such inconceivable values that electrons are literally crushed into protons. Rock, iron, and metal cease to be solid matter and turn into exotic plasma. Gravity tries to crush the planet inward, and if the mass exceeds a critical threshold, a chain reaction is triggered. Yes, you are seeing this right. Our rocky planet ignites. Due to the colossal pressure, thermonuclear fusion begins inside it. Earth has just become a star. And not just a yellow dwarf, but an aggressive, hyperdense monster radiating incredible levels of radiation. And now, let's zoom out the camera and look at the map of the solar system as a whole. For billions of years, everything here obeyed one rule: a massive sun in the center and lighter planets revolving around it. But there is a new boss in the system. Since our Earth star is now 4 times more massive than the old sun, the center of mass, the so-called barycenter, sharply shifts toward us. Look at what is happening to our good old sun. It is torn from its usual central place. Our former home star, which once gave us warmth, now obediently orbits the scorching mega-Earth in an incredibly elongated trajectory. We have just single-handedly turned the solar system into a binary star system. 2 suns begin their gravitational waltz. For the rest of the planets, from tiny Mercury to distant Neptune, this means absolute chaos and certain doom. The cross-gravity of 2 giant luminaries literally breaks their orbits. Gas giants like Jupiter and Saturn get caught in the crossfire of double radiation and begin to rapidly lose their atmospheres, leaving behind giant comet-like tails. And the remaining rocky worlds simply evaporate in this gravitational dance of death. The entire system turns into a cosmic meat grinder. The experiment is officially complete, and it proved one mind-blowing thing. Size in space is only half the battle, if you don't account for density. If our small, rocky Earth somehow magically grew to the size of the Sun, it wouldn't just take its place. Because of its incredible mass, it would overpower it, bend our star to its will, ignite with its own flame, and plunge our entire world into absolute fiery chaos. If this insane thought experiment broke your brain as much as it did mine, and you watched all the way to this point, hit that like button right now, and let's keep this series going, because the universe is limitless. Head down to the comments and write who or what should we shrink, enlarge, freeze, or blow up in the next episode. Maybe make Jupiter the size of Earth and see if it turns solid, or replace the Sun with a supermassive black hole the size of a coin. I read absolutely all of your ideas, and I'll make the next video based on the most liked comment. Be sure to subscribe to the channel and hit the bell so you don't miss the result of your challenge. Thanks for watching, and see you in new simulations.